Hello everyone, welcome to my video. In this video, I would like to explain about the machine learning. Now, today's agenda is defining machine learning, deep learning, and artificial intelligence terms. Finally, further going with machine learning and its types and linear regression model implementation using TensorFlow. Let's see artificial intelligence. It is a field of computer science aims to make computers achieve human-style intelligence. In the olden days, artificial intelligence was implemented like set of instructions given by the developer so it can perform certain tasks. It can be achieved with expertly programming in the olden days. But nowadays, they have many approaches to reach this goal, including machine learning and deep learning. Here, machine learning is a subset of artificial intelligence. We can say a set of related techniques used to make the computers train so then perform a particular task rather than explicit program. In simple words, we are training the model which takes the input and output and predicts the function that maps the input and output. There are different types of machine learning we can see in them, but here deep learning is a subset of machine learning. So you can say it uses multi-layer neural networks to perform certain tasks. And there are another models that can be involved in deep learning. We'll discuss about them later. And machine learning and deep learning shares most of the models similarly, so there can be used interchangeably. Now let's see machine learning types. There are different types of machine learning are available based on the how models learning. Yep. So supervised learning means our models learn by taking input as well as output. Whereas unsupervised learning, our models only see the input value. And reinforcement learning means it depends on the feedback value like that. And there are different types of machine learning types like semi-supervised learning, transfer learning, and so on. Now, for the foundation, we are just learning this. Let's see what is supervised learning. Here, it's like learning under the supervision of someone for us. And when we talk in general, here our model receives the input and as well as the output. And our model learns the functioning, the input and output values. Let's see, they have two types, regression and classification. Let's see the regression now. So regression, we can have different type of regressions like linear regression, logistic regression, multilinear regression, polynomial regression, and so on. Let's see what is linear regression. Linear regression includes the finding the relationship between input and outputs, or in other words, we can say the finding the relationship between dependent and independent variables in mathematical terms. But in machine learning, it's finding the relationship between features and labels. Whereas features are our input values and labels are what we need to find. Well, in the given equation, you guys can see that y dash equals to p plus w1 x1. This is a simple mathematical equation we can find we can use it to find a line in the set star slope. Well, y is the term we need to predict. We can say it is a dependent variable, whereas x1 is our input variable or feature value, and w is the weight as well as piece powers. But when it comes to the multiple linear regression, it has more number of input values than output value. Because when we are predicting the weather, how how weather quality or how weather changes for a week, we can consider a lot of factors affecting its conditions, like humidity, air quality, temperature, and so on. So for 7 days, we take different type of inputs. But what we need is only certain output that tells us it is cloudy, it is rainy, it is sunny, like that. So we are having y equals to b0 plus b1 x1 and so on equals to epsilon. Or we can say it is a Bayer or error term. Here y is the dependent variable, whereas x1 and x2 and so on are independent variables. B was the intercept, means we can say slope in mathematical terms, whereas b1, b2 are coefficients. Now let's see the implementation of linear regression using TensorFlow. Now let's get into the implementation of linear regression using TensorFlow. First of all, we need to import the TensorFlow. It's a Google API. In the next video, I will to explain about it. as well as we need to import the numpy. It is a Python library which stands for the numerical Python. Here we're defining two terms x and y, which are also known as independent dependent variables. Here y we need to predict, so it can be called as target variable, whereas x is our input features. And we are defining the or taking normal random values for the weights and biases. And finally, we are defining our model, which will return the multiplication of x and weights plus bias. Now defining the loss function, so we need to build how much loss of our data is going to be when we train the model and making predictions. So it will tells us how our model perfectly predicting. And for that we are using the optimizer which will use to optimize our model is gradient descent. Finally, let's get into the loop where we are letting our model to see the our input x values 1,000 times. And for the gradient type means it is the auto differentiation in TensorFlow, which will print takes every, I mean, which will print, takes or remembers every step in the forward pass and use it to update our weights in the back propagation of our model. So our model can predict perfectly. And we are printing for every 100 steps how our loss will be changing and the step number 2. Now let's run this one. Oh, well, there. So you guys can see it is printing step 0 from onwards. Here our loss is mainly decreasing as well as increasing and finally decreasing. Yeah, our total trained weights as well as our voice is minus 0.3. When it comes to the R squared error, it will mainly used for prediction purpose. I mean, how much our value could predict is 1.0. We got 1.0. So it is a Gaussian, okay, we can say our model is 100% predicting.